today we'll start our new topic, and for today we'll start with our new topic, that is the combinational circuits. Fine. So till now we have studied various things in the digital electronics, and that were logic gates, Boolean algebra, and how to solve the K-maps and all. So now we'll start with our new topic today, and that is the combinational circuits. So in this, you will be studying that what are the combinational circuits and what are the different types of the combinational circuits, how to deal with those combinational circuits, and means how to analyze and how to design those different combinational circuits, and how to solve the questions related to the combinational circuits. Fine. So now coming to the first part, that is the introduction of the combinational circuits, we can say, or yes, we can say that the introduction of the combinational circuits. So first we will understand that what are the combinational circuits. Fine. So here you can see it is written that combinational circuits are a type of digital logic circuits in circuit in electronics that perform a specific logical operation on one or more input signals. Okay, on one or more input signals. Fine. On one or more input signals to produce an output signal based solely on the current values of the inputs. Fine. So what is a combinational circuit? So combinational circuit is basically a type of digital electronic circuit that performs a specific operation or a specific function for which we have designed it or for which we have programmed it. Okay. So based upon the input signals, okay, some input signals are being applied, and based on those input signals, it produces a particular output signal. Okay, and these output signals that we are getting here in the combinational circuits are solely dependent on the current values of the inputs. Fine. So these are basically dependent on the current values of the input signals. Okay. Was when we will be studying the sequential circuit, then there we would see that output is dependent on the current values as well as on the past values also. Fine. So in the combinational circuits, output is basically dependent on the current values of the inputs. Okay, these circuits don't have any internal storage elements. Okay, so next point about these combinational circuit is that these circuits don't have any internal storage elements like flip-flops or registers. Okay, to store past input or output values. They generate their output solely based on the current input values. Okay, so these combinational circuits don't have any storage element. Okay, so these combinational circuits don't have any storage element, so they can't store the values of the past input or the past output. That is why they basically generate the output depending upon the present or the current values of the input. Okay, now here in the this is basically the block diagram of a combinational circuit. This is basically the block diagram of a combinational circuit. Okay, so in the block diagram of a combinational logic circuit, you can see that n input variables are being given. Okay, and based on means n input variables are being given, here some combinational circuit or some logic would be implemented. Okay, and based on these input values, it is generating some m output variables. Okay, based on these input values, it is generating a output variable, or output variable, or you can say output is being generated. Fine. So this is basically the introduction of the combinational circuits. This is basically the introduction of the combinational circuits. Fine. Now next, coming to the key characteristics of the combinational circuits. Okay, next coming to the part that is the key characteristics of the combinational circuits. Key characteristics of the combinational circuits. Fine. So basically I had introduced three basic key characteristics of the combinational circuits, and that are first is deterministic behavior. What this key characteristics means: deterministic behavior basically means the output of a combinational circuit is entirely determined by the current input values. Okay, there is no memory or feedback mechanism, so the output depends only on the logic equations that describe the circuit. Okay, means the same point that I have explained to just now, that in the combinational circuits, the output is solely or wholly dependent on the current input values, as these combination circuits don't have any storage element, so output is not dependent on the past values of the inputs or the outputs. Fine. So this is the deterministic behavior. Okay. Now second key characteristic is no clock signal. Fine. So in the combinational circuits, combinational circuit do not rely on a clock signal for their operation. They respond immediately to change in the input values. Fine. It means that in the combinational circuits, clock signal is not required. Means for generating the output, clock is not required, and the output changes as soon as the input applied to the combinational circuit is changing. Changes means as soon as the input changes, the output also changes. Fine. As soon as the input applied to the combinational circuit changes, output also changes. Fine. Now, next coming to the third part, that is the logical operations. Next coming to the third part, that is the logical operations. Fine. So, combinational circuits are built using logic gates such as AND or NOT, XOR, etc. And they can implement various logical functions like addition, subtraction, multiplication, division, comparison, and etc. Fine. So, these can perform the logical operations, and means these combinational circuits are basically made by using the simple logic gates, or you can say by using the logic gates such as AND or NOT, XOR, etc. And these can perform different functions like addition, subtraction, multiplication, division, and etc. Fine. Now coming to the some common examples of the combinational circuit includes multiplexers, demultiplexers, adders, subtractors, encoders, decoders, and various other digital logic blocks used in the digital systems, microprocessor and integrated circuits. Fine. So some of the basic common examples of the combinational circuits include multiplexer, then demultiplexer, adders, subtractors, encoders, decoders, and various other digital blocks that are used in the digital design system or the integrated circuits. Fine. So these are the basic three characteristics of the combinational circuits. Okay. So in summary, we can say that the three characteristics of the combinational circuits include: first is deterministic behavior, second is no clock signal is required for generating the output, and the output is generated, or output changes as soon as the input applied changes. Fine. And the third is logical operations, means combinational circuits are built using logic gates, and it can be used to perform the various logical operations such as addition, subtraction, comparison, etc. Fine. So this is the basic, or you can say this is the key characteristics of the combinational circuit. These are the key characteristics of the combinational circuits. Fine. Now coming to the next part. So here in this lecture, what we would be studying, the basic building block, or you can say the basic element of the combinational circuit, that is the multiplexer. Okay, the basic element or the most commonly used element, that is the multiplexer. We would be studying here in this lecture. Fine. So now coming to the multiplexer. Fine. So what is a multiplexer, or you can say multiplexer, commonly referred to as a MUX, fine, is a combinational circuit. It is a combinational circuit that selects one of many input data lines and directs it to a single output line based on a set of select lines. Right? So what this particular multiplexer does, now here in this multiplexer, various input data lines are present. And some select lines are present over here. Fine, some select lines are present over here in the bottom side. So what this does, it selects one of the data input lines based on the select lines and directs that input to the output. Fine. So this is the basic function of the multiplexer. Now ये क्या करता है basically? This multiplexer what it does, ये basically जितनी भी input data lines हैं उनमें से बेस्ड, मतलब जो हमारी सेलेक्ट लाइन्स है, उन सेलेक्ट लाइन्स के कॉम्बिनेशंस के अकॉर्डिंग उस पर्टिकुलर डेटा लाइन को सेलेक्ट करके और क्या कहते हैं उसको लिंक कर देता है आउटपुट के अक्रॉस। फाइन। तो हमें क्या कहते हैं बेस्ड ऑन द कॉम्बिनेशन ऑफ द सेलेक्ट लाइंस यहाँ से कोई एक डेटा लाइन सेलेक्ट होती है और वही आउटपुट हमें यहाँ पे आउटपुट में मिल जाता है। फाइन। तो what a multiplexer does, a multiplexer commonly referred to as a mux also, हम लोग क्या कहते हैं, हम लोग mux भी कहते हैं। Fine. Is a combinational circuit that selects one of many input data lines. It selects one of many input data lines and directs it to a single output line based on a set of selected lines. Fine. Here is a simple block diagram of a multiplexer. So here is a simple block diagram of a multiplexer. Now what these are the data input, these are the data inputs. Fine, these are the data inputs. Now and one enable input is also present over here. These are the select inputs, or you can say the select lines. These are the select inputs or the select lines. Fine. And this is our output, this is our output. And when we are writing the multiplexer, so we write it in the form of n is to 1. What is this? Is n? This is basically the number of inputs. This is basically the number of inputs. This is basically the number of inputs. Right? Number of inputs. So this is the basic representation of the multiplexer, or you can say MUX. Fine. This is basically a normal representation of a multiplexer or a MUX. So I hope that you would have understood it till now, that what is a combination circuit and what are the key characteristics of the combination circuits, and we have and then what is the multiplexer. Fine. Basic definition of the multiplexer you would have understood it till now. Fine. Now coming to the start. Now we would start with the multiplexer. Fine. So the basic multiplexer is 2 cross 1 MUX. Fine. We have written 2 cross 1 MUX. So what does the 2 cross 1 MUX means? In 2 cross 1 MUX, in this basic notation, what we can see that this is the input. Fine. And these many outputs we are getting. Fine. So here in the block diagram also we can see that the two inputs I0 and I1 are present, and one select line is there, and output is 1. Output is 1, and that is the Y. Fine. One output is present, and that is the Y. Fine. Now how we can see means if we can see total how many inputs are present, 2. Fine. So inputs are generally present in 2 to the in the means in the general representation of 2 to the power n. Fine. So here inputs are input is 2 to the power 1, that is giving us 2. So whatsoever we are getting over here in the power, these many select lines we use, and these many select lines we use. So here we are getting in the power as 1, so we are using only one select line. Fine. So we are using only one select line. Okay. Now we can observe that one second. Now we can observe that based on now we can observe that what we can observe that this select line means this can have two values. Okay, this can have two values. What these two values can be? S can have either the value 0 or the value 1. Okay, this select line S can have either the value 0 or the value 1. Now just simply understand how this means multiplexer works. Fine. Just simply understand how this multiplexer works. Fine. Now when S is 0, or we can say S is 0, this is for S is equals to 1. Fine. Now when S is 0, this would be connected to this output. Okay. Fine. When S is 0, I0 would be connected to the output. Okay. And when S is equals to 1, this I1 would be connected to the output. Fine. So this is the basic working of the multiplexer. Means when S is 0, this I0 would be connected to the output, and when S is 1, this I1 would be connected to the output. Okay. This is also written over here. When S is 0, in the output we would get I0, and when S is 1, we would get in the output I1. Fine. Now, based on this particular table, we can write down our output equation also. 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 From here, what we can write down as our output equation? So output is y. Output is y. Now, for s being 0, it would be represented as s bar I naught plus for s equals to 1, so s I1. Fine. So this would be our final output equation. So this would be our final final output equation. How we are getting it? When s is equals to 0, we are getting y is equals to I naught. When s is equals to 1, we are getting y is equals to I1. Right? When s is equals to 0, we are getting y is equals to I naught. When s is equals to 1, we are getting y is equals to I1. Fine. So these are the basic functionalities that we are getting. Okay. And based on this, we can write down this particular table information in the form of this output equation. The output equation would be s bar I naught plus s I1. Fine. Okay. Now, so this was our basic 2 cross 1 MUX. I hope you might have understood it till now that how this 2 cross 1 MUX works. Fine. Now, coming to the next part. Okay, so this is the output equation. Okay, this is the output equation. So this is the output equation. You can see the output equation is y is equals to s bar I naught plus s I1. Fine. So this is the output equation for this particular 2 cross 1 MUX. Okay. Now next coming to the 4 cross 1 MUX. Next coming to the 4 cross 1 MUX. Fine. So in the 4 cross 1 MUX, now you can easily understand that how many inputs are present in the 4 cross 1 MUX. This is the input. Fine, and this is the output. So, in case of the MUX or multiplexer, output is always 1. We get only one output. Fine. Now, how many inputs are present? So inputs are 4. Now this 4 can be written it in the form of 2 to the power 2. Okay. So from here we are getting in the power 2. So these many select lines would be present. So these many select lines would be present. So here we are having two select lines. One is S0 and one is S1. Okay. So here we are getting two select lines. One is S0 and one is S1. One is S0 and one is S1. Fine. Now we are having 4 inputs I0, I1, I2 and I3. We are having 4 inputs I0, I1, I2 and I3. Fine. Now here in this case, when nothing is present, so this is the LSB and this is the MSB. Fine. This is the LSB and this is the MSB. Okay. Now coming to the combination. So for two select lines, how many combinations would be possible? For two select lines, 4 combinations would be possible. So these 4 combinations are being written over here. Fine. 00, 01, 10. Oh, sorry. It would be 1, 1. Okay. It would be 1, 1. Fine. It would be 1, 1. Okay. Now, so for these many combinations, okay. Just a second. I would just get it. Okay. So it would be 1. Fine. Fine. So here it would be 1. So this combination is 1, 1. Okay. So now when on the select lines we are having 0, 0, then which output would be selected? I0. Fine. So here in this case, I0 would be selected. And when we are having the combination is 0, 1, then which output will be selected? I1. So I0 would be selected when these select lines values will be 0, 0. I1 would be selected when these select lines values will be 0, 1. I2 would be selected when these values would be 1, 0. And I3 would be selected when these values would be double 1. Fine. So these are basically the what you can say possible combinations when depending upon the values of the select lines, these particular input lines would be passed or matched with the output. Fine. So this is basically the representation, or you can say what you can say. This is basically the functioning or the working of the 4x1 MUX. Fine. Now, based upon this, we can write down the output equation of this particular 4x1 MUX. Based upon this, we can write down the output equation of the 4x1 MUX. Okay. Now, what we can write down in the output equation. So here, okay. Now here, what you can observe, we can write out the output equation as y is equals to S1 bar. Now here we can write down y is equals to S1 bar, S0 bar, I0. Fine. Plus S1 bar, S0, I1. S1 bar, S0, I1. Plus S1, S1, S0 bar, S1, S0 bar, and I2. Plus S1, S0, and I3. S1, S0, and I3. So this is basically the output equation. Fine. You can match it with the equation written over here. S1 bar, S0 bar, I0. S1 bar, S0, I1. S1, S0 bar, I2, and S1, S0, I3. Fine. So this is basically the output equation of this particular 4x1 MUX. Okay. So in the 4x1, what is the summary of this 4x1 MUX? The summary of this 4x1 MUX is that in this 4x1 MUX, 4 inputs are available, 1 output is available. And what are these 4 inputs? I0, I1, I2, and I3. And for selecting these 4 inputs to get a particular output, we are having two select lines. S0 and S1. Okay. Now, based on the combination of these select lines, one of the input would be selected and that would be displayed on the output line, or you can say on the output bar. Fine. So this is the basic of you can say 4x1 multiplexer.